So here in this question, we are going to try to figure out area under the curve using a concept called Riemann sum. So let's read. Estimate the area under the graph. The graph is x squared, so let's try to draw the graph. The graph of x squared is a parabola passing through 0, 0. So it looks something like this. This is 0 from interval 0 to 2. So let's say this is somewhere 2 here. Okay. So they want us to find area under the curve from 0 to 2. Basically, they want us to find this area. Okay, all this highlighted area. Asking you to do three different ways. First left side, then right, then midpoint. So let's try left side first. Left side, the starting with you need to find delta x. Delta x is same for all three cases. Delta x is b minus a by n. B here is 2, a is 0, n is 4. Okay, so 2 minus 0 by 4, the answer is 1 by 2. So what that means is you need to divide the interval into 4 equal intervals, and their all width is what? 1 by 2. So 4 equal intervals, each is the width of half. So the first one is half, half plus half, 1. 1 plus half is 3 by 2. So these are the 4 intervals. Okay. So left side means you start from 0. So x naught is equal to 0. Then the next point x1 is equal to half. So you're going to draw a rectangle with f of 0. F of 0 is just 0. So that is just the line. That's not even, because f of 0 is 0. And then f of 1 is this much. You're going to draw a rectangle with the width of half. The width is same, okay? And height of f of half. F of half is this much. So that would be half square, f of half. Then f of 1 is this much. Let's say this is f of 1. And I draw a rectangle at that value, f of 1. The width is again same, half. Then f of 3 by 2, this much is f of 3 by 2, and the rectangle draw here, that is the last rectangle. So we are saying if we find area of these 4 rectangles, then that estimate approximately the highlighted area which we colored starting. Okay. So how do you find area of these 4? The first one is height is f of 0 times delta x, plus second one here is f of half times delta x, plus this one f of 1 times delta x, plus last one, how much is this? F of 3 by 2 times delta x. You see delta x is same, can be factored out. F of 0, 0 square. F of half, half square. F of 1, 1 square. F of 3 by 2, 3 by 2 square. And we also know that the delta x is half. So we can just put delta x here. So you can put these values. Half square is 4, 1 square is 1, 3 by 2 square is 9 by 4. If you calculate this all by putting in the calculator, this is 1.75. So we are estimating that the area under the curve is approximately 1.75. Let's work on part B now. The part B is saying from right side, the right end point. Okay. So let's draw the graph. Again, the parabola is your x square, right, passing through 0. We need to look from 0 to 2. That means basically we need to find area under the curve from 0 to 2. Again, delta x part is same for all three things. So we're going to divide into 4 equal parts. The first part is 1 half. The second part is also 1 half. 1 half plus 1 half is 1. 1 plus half is 3 by 2, and plus half is 2. Okay. But now we're going to start from the most right end point. The most right end point is 2. The function's value at 2 is this length. we're gonna draw a rectangle at that length. So that is your first rectangle. Okay, width is same. What is the area of this rectangle? Delta x times f of 2 plus the next point is 3 by 2. F of 3 by 2 is this value, and I draw a rectangle at that height. So that's gonna be f of 3 by 2 times delta x plus at one's height is this, at that height rectangle is this, area of that is f of 1 times delta x plus at half the height is this, draw the rectangle at that height, that's gonna be f of half times delta x. So now we are saying we are estimating the area under the curve using these rectangles, right? So they are a little bit more, but they are approximately close to that. Again, delta x can be factored out. F of half plus f of 1 plus f of 3 by 2 plus f of 2. F is x square, so that is delta x is half square plus 1 square plus 3 by 2 square plus 2 square. If you put that all in calculator, we are getting 3.75. So you remember from left hand side, we estimated the area to be 1.75. From the right hand side, we are estimating it is 3.75. Now we have one more case, that is the midpoint Riemann sum. Let's work on the midpoint Riemann sum now. That midpoint means that now we are going to take our points from the midpoint of intervals. So let's see. We have our parabola x square. We want to do the area under the curve until 0 to 2. So again, we still want to estimate that area. We are still going to divide the area, the width from 0 to 2 into 4 equal portions. They are same, half, 1 plus half is 3 by 2. Okay. But now for each the interval, we are going to find the midpoint. So midpoint between 0 to half will be 1/4. Midpoint will from half to 1 would be 3 by 4. Midpoint here would be 5 by 4, and midpoint here would be 7 by 4. So what we are doing is we are finding the function's value at that midpoint and finding rectangle at that height. Okay, midpoint function value and finding the rectangle at that height. Midpoint at the function's value. So this is the height of the function, but this is the rectangle. Midpoint here. So this is the height of the rectangle, but this one is the rectangle. Okay. So let's write down the areas. Each of them width is still delta x. So delta x still can be factored out. But the height of the first rectangle is f of 1 by 4. Height of the second rectangle is f of 3 by 4. F of 5 by 4 plus f of 7 by 4. Okay. What is that? Delta x is still half. F of 1 by 4 is 1 by 4 square plus 3 by 4 square plus 5 by 4 square plus 7 by 4 square. Half 1 by 16 plus 9 by 16 plus 25 by 16 plus 49 by 16. We can put it all in the calculator, getting 2.625. Now I want to remind you, we did 3 cases. Okay, the first one was left, then right, and the middle, right? I'm writing middle in between for a reason. When we found area using left, we got 1.75. When we found area using right, we got 3.75. And the middle area is 2.625. So obviously the middle is lying between left and the right area. Left was a little less, right was a little more, and the middle one is somewhere in between. So these are Riemann sums to calculate area under the curve from three different ways.